Well, welcome once again to LPAC Shorts, the ongoing series where we take up subjects that are of interest and pertinent to being able to understand exactly what it would take to get the economy going in the United States again, to re-Americanize the U.S. economy, if you, so to speak, if you want to put it that way. And we're joined today with by Brian Lantz once again, who's a longtime associate of Lyndon LaRouche and economics researcher in his own right, who has been studying this subject. Last week, we talked a bit about the supply chains and some of the challenges that are involved in that. Today, we want to actually review along the same lines, but by take up an example of what the real challenge is for the United States to become a manufacturing and industrial power. And that is to discuss the situation with steel manufacturing in the United States. Now, I think, as everybody knows, steel is a essential feature towards any modern economy, both on just a basic structural level, but also even in terms of advanced technologies and so forth. Everything has steel in it. Everything needs steel. And it's not just one kind of steel. There's lots of kinds of steel. So it's as basic as food or energy for the economy. And the U.S. used to be one of the big powerhouses in steel production. We used to have big steel manufacturing, famous companies, U.S. Steel, Bethlehem Steel, the Bethlehem Steel Sparrows Point plant in Baltimore during the height of World War II employed almost 100,000 people. Even well into the 1970s, 35 to 40,000 people were employed there. So steel is the basic bedrock of a manufacturing economy. And so we want to take a look at this, since Brian has done some interesting research on it, to catch people up as to where we actually are, so that the concept of re-industrializing America actually has some backbone in it. It would put some steel concept for you. So yeah. Brian, why don't you tell us what the situation is with steel now, which might shock a lot of our listeners.
Yeah, steel as opposed to stealing.
Yeah, right.
I think the first thing to say is you can't really sort this out, or what we've been presenting over the last several weeks, without the standpoint of physical economy, the science of physical economy. And yet one has to bring this to these concepts or these areas of the economy, like steel, to be able to fathom, okay, what's needed, what isn't. And I think that includes the labor force. The labor force needs to understand physical economy, to understand its own appropriate role, and we as citizens to look at these things. So I just wanted to say that off the top. But if
that's
you look
a good point.
I'm sorry?
No, I just said that's a very good point to make at the outset.
Yeah, okay, good. So today, we've got just 9 integrated steel mills left in the United States. Those are, the big steel mills, including, coke ovens and blast furnaces and oxygen, the basic oxygen furnace plants, all combined, that takes iron ore itself, and turns it into, at the other end, steel. We've got about
only 9.
Only 9 left. We've got 112 what they call mini mills. These are electric arc furnace mills that only use scrap metal. They actually do need coal. They need other aspects, but in terms of their coal, they're not taking iron ore. They're using scrap metal and reprocessing it back into steel. Well, first of all, it should be clear, if we're going to expand the economy, since we're operating at about 90% of steel capacity right now in the United States, and on top of that, we're importing 20% of our steel, thereabouts, we simply can't continue to exist on scrap metal. There's no growth there. We're simply recycling. So the growth has to come from the expansion of integrated steel mills to expand production. And I think that's a really important idea, basic idea to have in approaching.
Well, how much do we produce out of these 9 plants that are left?
That's about 30% of steel production. The U.S. is right now producing about 90 million tons of steel a year. That's out of a global production of about 2 billion tons of steel a year.
And it's only 80% of our current consumption, right?
Yeah, 30%. 30% of our current consumption is produced in integrated steel mills. 70%.
And then there's the reprocessing and recycling of scrap metal.
Absolutely. Yep.
All right. Give us a sense of actually how much steel we really do need to consume. That is, if we're actually rebuilding the U.S. economy, what would be the steel requirements?
Well, first, I think we could look to nuclear energy. We've talked about it in the past. These shorts, LPAC shorts. If we take nuclear power, we take the example of needing 200 gigawatts of nuclear power if we're going to triple the manufacturing base of the economy. That's based on about 8 to 10 kilowatt hours per day per worker, manufacturing worker. You know, if you increase that utilization rate, you're going to need more, but let's use that as a starting point. Well, 200 nuclear power plants, there's about 200 million tons. Let me make sure I've got the figure right here. 20,000 tons of steel go into a single nuclear power plant. So just to build 200 gigawatt, 1 gigawatt nuclear power plants, well, you can do the math yourself. We're going to need a few million tons of steel to accomplish that. But that's just for nuclear power plants. And that's, of course, just one feature of nuclear power plants. That's the basic stainless steel of different types that goes into a nuclear power plant. If we then add on top of that, for example, rail, we're talking about needing another 3 million tons of stainless steel if we're going to significantly expand our freight and passenger rail system. Just using as a ballpark about 15,000 miles of rail, freight or high-speed passenger. But just to give an idea, you're talking already about 5-6 million tons of steel that would be required. And then really keeping in mind the drought circumstances sweeping the West, you know, which has now been going on for a decade, in fact, we need NWAPA, and that's going to require 300 million tons of steel. We're only producing 90 million tons a year. 300 million tons is just an approximate figure. So this is going to all require new utilization, since we're already operating at virtually 90%, virtually 100% of steel capacity right now.
And as we were talking before we went on the air here, even if you take the minuscule amount of money that this Biden infrastructure bill is, whether you take the $1.2 trillion so-called bipartisan package, of which only a minuscule amount is actual infrastructure, forget the 3.2 million. We probably, if we're at capacity, we've got to, we can't even do that. We can't even repair the roads and bridges and
it's a good point.
The tunnels they're talking about.
Very good point. And then you add in the energy requirements. We're around the country, we're basically maxing out at energy use, which is why we're facing brownouts and blackouts every summer or winter or whatever in different parts of the country. So yeah, the Biden plan, you know, it's in la land. We don't have the capacity. We've got to build that capacity, and that means a commitment to do it on the part of the American people, starting with the American people.
And we have to build those steel plants new. These are new plants, not just.
Absolutely. We've got plenty of coal. And as we discussed briefly last week, you know, the byproduct of coal production or utilization of coal is CO2, and CO2 is what plants eat. We've got to get past this this brainwashing on climate change and CO2, and anyway, we just got to get past that.
If you're a tree, CO2 is a friendly gas, not a.
Absolutely. Yeah, absolutely. So, you know, so then you have to think about, well, where do we want to put those plants? We've got a lot of coal out west. 50% of land in the western states is owned by the federal government, one department or another. But there's lots of natural resources there, including iron ore. If we're talking about developing the empty quarter, you know, between basically the Midwest and the West Coast, between Texas and California, if we're talking about developing that empty quarter with projects like the WAPA and so forth, that's a place you'd want to cite new steel capacity, because you have the coal, you have the iron ore, and that's where you can utilize that new capacity for nation building.
And the construction of these steel plants also will consume a lot of steel, right? And a lot of other resources. I mean, yes, what's involved in actually picking up from scratch, building up from scratch a modern integrated steel manufacturing facility?
Well, I'm not an engineer. I'll just skim over it, but you know, you're talking about the coke ovens, which are enormous facilities, because you have to take coal and turn it into coke, which is basically pure carbon, for the blast furnace process. That's just one step. There's the blast furnaces. These are among the largest industrial engineering plants in existence. They require about 1 gigawatt of power each, gigawatt in coming from natural gas or other forms, not purely electricity, but a total of about 1 gigawatt of power per plant. And then you have the oxygen, the basic oxygen furnace, where you're blowing pure oxygen, you know, over the hot, what we used to call pig iron, right, to decarbonize it, to get it down to basically a less than 7% carbon in the steel, and then there's many further steps depending on what kind of steel you're producing, what kind of alloys. There's also a different after what should we say, after product processes, the quenching of steel. You know, Japan, China are now producing rail for railroads that are 100 meters to 150 meters long. In other words, they're a football size in length or a football and a half in length, a single continuous piece. And that requires, again, a very high quality, specific type of steel. So it's an enormous process. If you just take the blast furnaces itself, it gives you an idea, I think, of what's involved.
So it would require rebuilding also America's machine tool industry, because to make the parts and the tools and all the components that go into a big steel mill would require a huge increase in the output of machine tools and other areas of the economy. I remember back in the 60s and 70s, my father had worked in the steel industry, and that the steel industry was like the basic industry that made all the industries run. People used to talk about the automobile industry, but it was actually the steel industry which everybody was worried about. And of course, there was that famous case under the Kennedy administration where Kennedy took on the steel barons in order to force them to lower their prices so that the steel production could actually function and be a basis. So, you know, I think this gives you a sense that, you know, even if, you know, you can't do anything in the economy or remanufacturing unless you think about something as basic as steel. And with everybody thinking about microchips, they're missing some of the actual things.
The three basic industries in the world today are coal, oil, and what we're talking about right now, steel. Those are the three basic largest industries in the world. The world absolutely requires them, and we need a lot more utilization of all and production of all.
Well, that's a good declaration to to wrap up here, because that's not the way anybody's thinking, right? They're thinking small. They're thinking, you know, microchips and wafers and plastics and this kind of thing, all of which we need, right? But even if you're going to build a microchip foundry, you got to have a lot of steel to do it, and you got to have a lot of energy to do it. Even, you know,
40% of steel right now in the U.S. goes for construction, basic construction. You know, autos is 20% of steel, autos and trucks. Anyway,
well, that's important, because you can see that the current housing crisis is in part due to the money printing and so forth that the Fed is doing, which is artificially raising the price of housing for financialization. But there is a legitimate shortage of housing, not just moderate and low income housing, but just in general housing in most of the country. And that requires a huge input of steel, especially for
apartment buildings. Yeah.
Apartment buildings and so forth, or if you're going to expand our medical facilities and educational facilities and so forth.
And those foundries, those computer chip foundries.
Right. So the idea that the United States should be satisfied with 9 fully integrated steel manufacturing facilities is a little bit ridiculous. So I think your point that, you know, the world runs on coal, oil, and steel still does, no matter how fantastical you want to be about how we're now entered into a new economy. What is it they call it, the fourth industrial revolution, where everything runs on microchips and brainwaves or something like that.
To build robots, you got to have steel.
There you go. So that's what we want: build steel and stop the steal.
That's right. Exactly.
Okay. Well, thank you for joining us today, and we look forward to talking to you next time in the LPAC Shorts.
Great.